Hello, friends. My name is Kevin Delaney, and this is the Museum of Discovery in Little Rock, Arkansas. We're going to show you some awesome science. Kendall, come here. Kendall, before we begin, I need you to protect yourself. Please put on your goggles. Please put on your science earmuffs. And please put on your science mittens. Now, what we're going to be examining today is something called phases of matter. That is solid, liquid, gas, plasma, and Bose-Einstein condensates. But we're only going to focus on the first three. So, Kendall, you know what a solid is, right?
I do.
Yeah. This hammer's a solid. I know it's a solid because I can hit it on a table and I can hear that, right? Because the solid molecules that make up this object don't really move too much. They kind of, stay together and they kind of vibrate. So a solid object like this will hold its shape. So we're going to look at a solid that's a little bit unique. Kendall, if I were to take an ice cube and I were to leave it out, what's going to happen to it?
Melt.
It's going to melt, right. That's phase change. It goes from a solid to a liquid. We're going to examine phase change in kind of a different way. But before I pick this up, I'm going to put on my gloves. Kendall, you okay?
Good.
Okay. This is frozen carbon dioxide, or dry ice. Dry ice is not water. It is frozen gas, carbon dioxide. Carbon dioxide gas freezes at a temperature of 109.3 degrees below 0 Fahrenheit. That is extremely cold. Cold enough to make copper scream. Did you hear that, Kendall? You've got earmuffs on.
I heard it.
Okay. The reason why that happens is because when this warm metal touches this cold, dry ice, it causes this phase change to increase in rate. This phase change is called sublimation. Kendall, can you say that with me? Sublimation. Sublimation is the direct transformation of a solid into a gas, and it is one of the most fascinating and beautiful scientific processes that the human eye can observe. So let's all observe it. That's amazing. Kendall, I'm going to give you a couple of pieces of dry ice. Will you please put them in those vessels that you see? You got your mittens on, right? There you go.
All of it?
Yeah, just the ones that are close to you. I'll help out. All right. How about this one? That one's kind of there. Kendall, can you put the lids on these two on that one? And the lid on this one. So what we're examining here is the rate of sublimation. And dry ice sublimates at a ratio of about 10 to 1, which means if I were to take a block of dry ice that weighed about a pound and I put it in a tank of water that had really, really high walls, that fog that you see there would fill that tank about 10 feet above the surface of the water because it takes up about 10 times more space. Kendall, why do you think these lids will not stay on these cans?
Because the gas is trying to escape.
Thank you very much, Kendall. We're going to move on. So when all of that carbon dioxide starts sublimating so rapidly inside of that pressurized environment, all of that pressure builds up a lot of strength, enough strength to pop the lids off if the lids are not sealed on there. So if we were to seal down the lids, Kendall, they would blow up, which is why they only sell dry ice to persons who are 18 years old and above. But you can buy it at the grocery store. Okay, so now we're going to look at a gas. So Kendall, I have this bowl of water here. And I'm going to add a little bit of soap. Can you grab some soap over there and pour it in there and stir it around? Here you go. Now take a sip. No, I'm just kidding. Don't take a sip. It's soapy. It's gross. Okay. So now, Kendall, what I have here is hydrogen. Do you know what hydrogen is? It's the H in H2O. It's the smallest, lightest, and most abundant element that exists in the atmosphere. Now, what I'm going to do is make a couple of bubbles using some of this hydrogen that I have and this soapy water that Kendall so brilliantly mixed up. Thank you, Kendall. Now, since hydrogen is such a light gas, it should cause all of these bubbles to fly. There it goes. So, Kendall, should we put hydrogen in all of our balloons to make our balloons fly really, really high?
No.
Why not? Would you like me to show you? Okay, I'll show you. Okay, ready? So, since hydrogen is such an abundant element, it's extremely friendly. It's very unique. So, it's very, very reactive, right? Would you like to try that, Kendall?
Sure.
Okay, so what I'm going to ask you to do, well, first of all, how many fingers do you have on your hand?
5 right now.
5, okay, we'll try to keep it that way. Okay, so I'm going to make some more bubbles inside of this bowl, and what I'd like you to do is scoop your hand inside the bowl, but when you do, make sure you get your hand all the way underneath the water, right? Okay, you can roll up your sleeve there too, I'll take your mittens. All right, so you said 5 fingers? All right. Flatten out your hand just a little bit. 5, 4, 3, 2, 1. Kendall, did you feel anything in your hand?
I felt heat.
Just a little warmth? Okay, here's what happens. You had water on your hand. So when all those hydrogen molecules ignited, all the water on your hand absorbed the heat from that fire and evaporated, leaving a little pocket of air between your skin and the bottom of the fire. So you had a nice little insulating layer there that caused your hand to be just fine. And now, how many fingers do you have?
Still 5.
Still 5, okay. So we're going to try to change that. Well, I mean, safely. Okay, so now in this beach ball, I have hydrogen and oxygen, about 2 parts hydrogen to 1 part oxygen, or H2 to O. Do you know what H2O is?
Yes.
It is water. Is there water inside the beach ball? No, of course not. Because what we're going to do is we're going to bind those atoms together to make water molecules. But in order to do that, we're going to need something called a catalyst. Cat Stevens, Cat Cora, Cat Power. That is a list of cats. A catalyst is a small release of energy that helps speed up a chemical reaction. So, okay. Now, where'd my hose go? Here it is. So now we're going to add a little bit of oxygen to our hydrogen combination here to see what happens. So, Kendall, you want to put your earmuffs back on because there might be a side effect here. Everybody else, put your earmuffs on. 5, 4, 3, 2. Did you hear anything?
I did.
What did you hear?
Explosion.
You heard a sonic boom. Here's what happened. When all of that hydrogen started to ignite, all the oxygen said, oh, fire. Because oxygen and fire work really, really well together. Because in order to have fire, you have to have a little bit of fuel, you have to have a heat source, and you have to have oxygen in the atmosphere. So when all those hydrogen molecules ignited, all the oxygen said, oh, and it rushed towards that flame. But since hydrogen burns so quickly, all the oxygen molecules continued to expand in a wave we call a concussive wave of energy that was expanding so fast that it broke the speed of sound, right? Do you know the speed of sound, Kendall? It's 762 miles per hour when you're on the surface of the Earth. So any object or force that moves faster than that will cause a vibration that we will all be able to hear, and that's what that is. Okay, so now, Kendall, we're going to do one last thing. I have another liquid. We've seen solids in dry ice. We've seen gases in oxygen and hydrogen. Now we're going to examine a liquid. So water is a liquid, obviously. Water boils at a temperature of 212 degrees Fahrenheit. Now, boiling doesn't mean hot. What boiling means is that once it's reached the highest temperature it can reach, a liquid starts to change. It starts to vibrate crazily and bubble like crazy and evaporate, right? So not all liquids do that at the same temperature, and nitrogen, which makes up about 80% of the air, in its liquid state actually boils at 321 degrees below zero, which is really, really cold. So, Kendall, I'm going to put my gloves on again, and I'm also going to put on some goggles to protect my eyes. I mean, I'm wearing glasses, but that's just so I don't bump into stuff. All right, so. So now, Kendall, can you see there is a liquid in this pot?
Yes.
Can you see that it is boiling, or appears to be boiling?
Yes.
What do you normally do when you have a pot of boiling liquid on your stove at home?
Spaghetti.
You put spaghetti in it. We don't have any spaghetti. What we have, though, is Cheetos, okay? Do you want to have a Cheeto? All right. So I have some Cheetos here. These are laboratory-grade Cheetos. So once I put them in the liquid nitrogen, what I'm kind of doing to them is frying them, except, backwards. So deep freezing or freeze frying. I don't know, whatever you want to call it. Now, what we're left with, though, is a really, really, really cold Cheeto. Kendall, do you think it would be safe or smart for a human being to eat this Cheeto?
Absolutely.
I'm gonna have another one. Kendall, you want one?
I do.
All right. So Cheetos have a lot of holes in them. And since they have all that surface area, there's an awful lot of space for all that liquid to go. But that liquid's going to just evaporate, right? So it super chills the Cheeto, and what you're left with is something really, really cold that you can eat. So go ahead. You just want to avoid letting it touch your lips, just to your teeth. Very good. Don't get Kendall angry, because she does that sometimes. Okay. All right, Kendall, how many balloons do you think we can fit in this pot?
I have no idea.
All right, there's some balloons around here. Can you hand me some balloons? So if you like going outside on a cold day and you forget your coat, you probably know what it looks like. Kendall, what do you do when you forget your coat and it's really, really cold outside? What do you look like if you've gone outside and you're not wearing a... Yeah, right. You're going like this. You're making yourself really, really close together. So as these air molecules get super, super cold, they condense just like that. They get themselves really, really small. And they actually condense into a liquid, which does not take up as much space as a gas does in this particular balloon. So all of the gas in there has now condensed into a liquid, and so it doesn't take up any room at all. So our balloons can fit all of them in this pot. But as those air molecules start to warm up, they expand again, as warm air tends to do. And so what we're left with are balloons that kind of, well, it used to be sort of dead, and now we're reflating themselves. Reflating, is that a word? I made up a word. That's okay. Shakespeare did it. All right, so now our balloons are starting to reinflate themselves. Now, Kendall, would you agree that this is pretty awesome science?
Pretty awesome.
Thank you very much. Awesome science is science that is awesome.